This video is going to cover how to calculate a centroid and a moment of inertia for a cross-section. The cross-section that we're going to use for this example is going to be a C shape, and the C is a grand total of 6 inches tall and 6 inches wide. Each of the little legs of the C and its web of the C is also 1 inch thick. Now to calculate centroid, effectively it's just a weighted average, and a weighted average for the x direction is going to be simply the sum of all of the individual for the piece is all of the individual x direction centroids times their area over the summation of all of the areas. Now the units for this are going to obviously be whatever distance you have for x bar, and areas are going to cancel each other because it's area over area. So effectively we need to take our shape and we need to break it into multiple other shapes. So for instance, I'm going to cut my little C right there, and I'm going to cut my little C down here. I'm going to call this top rectangle number 1. I'm going to call this vertical rectangle number 2, and we'll have another rectangle down here at the bottom, number 3. So effectively to find the centroid, we have to pick a direction. We'll say that we're going to pick this way to be where we're measuring from. So we're going to measure off of this wall here, and we're going to find out where our centroid is from that face. So to do that, we effectively need to find where is the center of all these individual pieces. So, this one is about here, this centroid's about here, and this centroid is effectively about the same spot as the other one, give or take. Definitely not to scale this drawing. So to find x bar, to find where the centroid is of this shape, somewhere, to find where that is, we need to take the individual distances to their little blue dots, multiplied by the area of the shape, and then divided by the area. That's for the x direction. For the y direction, it's mostly the same. It's the summation of the individual y locations times their area divided by their area. So again, this time we have to pick a new direction for y. It really doesn't matter up or down. Pick one and stick with it. Do actually make a note of it to yourself. We're going to go down for this one because why not? So again, we're going to be measuring for our y distance. We're going to be measuring it off of this top face here. So again, all you're going to do is find the vertical distance down from that top line to your blue dot for each individual shape and multiply it by its area and then divide by the sum of all of the areas. So it's really not too complex. So we can go ahead and get started solving for our x bar here. So we're going to do it based on shape. So we'll actually write our shapes and our colors here. So the x, we're starting with x, and again we are measuring from that purple line. So the horizontal distance over to the blue dot for the green rectangle, rectangle number 1, is going to be 6 inches divided by 2. The area of that one is 6 inches times 1 inch. Alrighty, and then we're going to add in our next one. Our next one is purple. And the distance over to the blue dot for the purple one is going to be 1 inch divided by 2. The area of the purple one is a base of 1 inch, a height though of 6 inches minus 1 inch minus 1 inch, which is 4 inches. So effectively reminding you that inside here is 4 inches. And then we're going to add, of course, now the red one, and the red one's distance horizontally is again going to be 6 inches divided by 2. Its area also 6 inches times 1 inch. And we're going to do all of that over the sum of the areas. So our first one, the green one, 6 inches by 1 inch. Then we have the purple one, and the purple one was 1 inch by 4 inches. Then we had the red one, and the red one is 6 inches by 1 inch. So we're going to find for this, when you plug it all in, 2.38 inches. Now again, remember that that is from that purple wall over. Just definitely note where that is. So it's going to be in here somewhere, not about where the 3 is, maybe a little bit before. Let's put a highlighter mark for it. So not at 3, it's probably over here-ish, maybe somewhere along there. And let's do the same for y bar. So what I'm going to do is I'm going to take this x bar stuff and I'm going to move it just so that we can keep y bar kind of in here. We'll come back to that here in a sec. So for y bar, we're again doing the same thing. We're finding the vertical distance, again, from the red line going down for each of these shapes. So for the green one, its vertical distance is 1 inch divided by 2. Its area is still 6 inches by 1 inch. Then we're going to have the purple one, and the purple rectangle, the distance vertically to its center is going to be 6 inches divided by 2. Again, so technically, I'm just going from here to the center, and that is obviously going to be the 1 inch plus the 4 divided by 2, which will be 6/2. Anyway, there's that, times its area, which again is 1 inch by 4 inches. And then we're going to add in our red one, and our red one is going to be, this one, we'll actually write it out. We have to get all the way down to here, and that is 5 inches. And then we're going to add in 1 inch divided by 2 to get to its center. Okay, so there's its distance, and its area is 6 inches by 1 inch. So all of that over the areas. So the areas, we're going to start with the green one. The green one, 6 inches by 1 inch. Then we're going to have the purple one, and the purple one is 1 inch by 4 inches. Then we're going to have the red one, and the red one is 6 inches by 1 inch. So we get grand total for y bar here. If you didn't already guess it, it is actually 3 inches. And again, that's from the top going down. So 3 inches does put it at the exact same height as that blue dot. So we found our centroid to be right here. Cool, so there's our centroid. Now with that information, let's calculate moment of inertia. So we need to know what is the moment of inertia, not only the x, but also in the y direction. So we're just going to kind of move that off to the side. And let's remind ourselves about a little bit of equations that we have. We're using rectangles, and if you need to look up anything that's not a rectangle, there's your good friend Google, and there's also the textbook. But for a rectangle, Ix is equal to 1/12 the base times the height cubed. Now this one's pretty easy to remember, and then if you ask anybody what Iy is, they kind of stutter and they go, oh, I don't know that one. But it's really simple. You just rotate the shape 90 degrees and it's the exact same thing. Yep, still a rectangle at that point. So it would then be 1/12 base times height, but since you rotated it 90 degrees, base and height are flipped. So it's height base cubed. Kind of cool, that one is. And what we're going to be doing is parallel axis theorem, because you see we have 3 different rectangles here, but not a single one of them has their center at point C. So we need the moment of inertia of the whole shape about point C, about its center, and you can't really do that with the rectangles that you're given. So we need parallel axis theorem. And parallel axis theorem states that the actual moment of inertia about the x-axis is equal to the moment of inertia about the x-axis for the individual piece, so say for instance the rectangle, plus its area times the distance y squared. And that distance y is from the center of the rectangle in question to the centroid, that distance in the y direction squared. Now, of course, if it's Iy, it's the same exact thing, right? It's going to be Iy for the individual shape plus the area times the distance horizontally from the center of the rectangle in particular to the center of the shape. So if you don't actually know the distance to the center of the shape, you kind of can't really get moment of inertia for the actual section. So noting these equations, what we're going to do, we still have our 3 little rectangles, so we're just going to go ahead and find Ix and Iy using parallel axis theorem for the individual things. So we'll just go shove that over there. So we'll do Ix for the first one. We'll just give it a sub 1 here so that we know that this is moment of inertia for the first one. So for the first one, again, remember that for a rectangle, it's 1/12. Base times height. We'll go ahead and just swap over and write everything in green here for this, related to this rectangle. So the base is 6, the height is 1. These are in inches. We're going to cube it, and then plus the area of this rectangle, which of course is 6 by 1 inches squared technically. And then we need dy. Again, so dy is going to be the distance technically that we'll try and pick a nice fun color we haven't used before. The distance that this green dot is to the center here. Now we do know the vertical distance completely we had was y bar, and that's going to be from the red line down to the blue line. And then we need to subtract out the distance from the red line to the blue dot, which is half of our vertical distance, which was 1 inch. All right, so I guess making sure that we know what is inches and what is just a random divide by 2. There you go. And we're going to square that value. And what we're going to get for IX1 is going to be 38 inches to the 4th. We'll do the same thing for y. So we'll do IY, but this is y1. So again, we've got 1/12, the height of 1 inch, the base of 6 inches, cubed, plus we need the area, 6 inches by 1 inch, that hasn't changed, times the distance from his center horizontally to the centroid. So that's going to be this distance here. So what is that distance? I would say that we have the total 6 divided by 2 here minus x bar. That's how I'm going to think about it. So again, we have the total x of 6 divided by 2. That's to the center of the blue dot of that rectangle. And then minus x bar. Good thing we found x bar. That value squared, and we're going to get 20.3 inches to the 4th. Okay, cool. Before we get too far, let's talk about the shapes individually. Yes, shape number 2 is going to be different, but shape number 3 is the exact same, right? Shape number 3 just is a different color here. Shape number 3 has the same width, the same height. It is the same exact rectangle, and his distance horizontally is the exact same as the top. What about his distance vertically? Is the exact same as well. The only difference between those values is going to be the fact that they're going to be negative versus positive, maybe, perhaps. But again, when you square it over here, it all becomes positive anyway. So technically, 1 and 3 are the exact same. So we don't need to do it again. We can just go with this is 1 and 3 for these things and call it a nice good day. Now let's do it for number 2 though. Let's do IX for shape 2, and then we'll do IY for shape 2. So again, it is a rectangle, so it is 1/12. The base of the rectangle though is 1 inch, the height of the rectangle 4 inches, as you recall. And we're going to cube that. Plus the area is going to be 1 inch by 4 inches. And then the distance, because this is IX, we need the Y distance, how far away his center is from the black dot there. And let me remind you that we drew that blue highlighter line right through it, so technically this distance is 0. And what that does is it actually cancels this whole part of it, because 0 squared is 0, and 0 times our area is going to give us 0, so really that shortens down our equation quite significantly. And IX for number 2 is going to be 5.33 inches. Inches to the 4th. Next we have IY for shape number 2. So again, that's going to be 1/12. We need the height, which is 4 inches, times the base of 1 inches cubed, plus the area. The area is 1 inch by 4 inches. times this time we want the x distance. How far away is our blue dot horizontally? So again, that is this distance. And I would say that that is technically the full x bar distance, but minus the half of 1 inch, that is the width. So 1 inch divided by 2. Square that, and you're going to get 14.5 inches to the 4th. So okay, so now what do we do now that we have all 3 of our rectangles, remembering that 1 and 3 are the same? Because it's a composite body, we're going to simply sum it all up together. So that means if I actually want Ix for the shape, I'm going to do Ix for 1, and I'm going to add in Ix for shape 2, and then I'm going to add in Ix for shape 3. Yep, sum them all together. So again, let's remind ourselves, Ix for 1 was 38 inches to the 4th, plus we have Ix2, which was 5.33 inches to the 4th, and then Ix3 being the exact same thing as Ix1 of 38 inches to the 4th, and we get a grand total of 81.3 inches to the 4th. We're going to do the exact same process this time for Iy. So again, it's going to be Iy for shape number 1, plus we're going to add in Iy for shape number 2, plus we're going to add in Iy for shape number 3. Put all that together, and what are we going to have? Iy for shape number 1, 20.3 inches to the 4th, plus for shape number 2, 14.5 inches to the 4th, plus shape number 3, the same as number 1, 20.3 inches to the 4th. We're going to get 55.1 inches to the 4th. Now technically there's multiple different ways to solve the same math problem, and this is one of them. You could break it down into a lot of rectangles, or let me show you another method. And this one is just as beautiful. So we're going to duplicate this guy and kind of move him off to the side here. Let's look at it from a different perspective. We still have the center, we still know where that is, and that's all great and all. But instead of having these individual shapes, how about instead we look at it with 2 other shapes? How about we pretend that we have one big shape? So I'm going to highlight these. We're going to have our one big shape here in red, and we're going to call that shape shape number 1. And then we're going to have, we'll do green, I guess. And then we have this shape, and this is shape number 2. So really what we're looking at is we're looking at a really big rectangle and then a really small rectangle that we have removed. So instead of summing them at the end, we're going to subtract them. And let's see if we get the same answer. Obviously we should, and that is the beauty of this thing. But is it any easier? Is it any easier? Well, let's, with our blue dots here, let's find the center of our squares. So it's a square, so it should be at 3 over and 3 up, which is about right here for, let's put a little marker for it. That's for 1. And for the other one, let's have a new distance in here, just to remind ourselves that this is 5, and of course this height we said before was 4 inches. And his center is at 5 divided by 2, so he's going to be, you know, ever so slightly right next to it, really. So I'm just going to put a little green 2 next to it. So there they are. If we wanted to put a nice highlighter through them, both of them though are at the same X spot. Y spot, Y ever so slightly different. So, and they're at the same Y location. X, Y's, they're a little bit different. So anyway, let's start off with IX for number 1. So for number 1, this is going to be 1/12, the base of 6, the height of 6, right? It's just really big square, cubed, plus the area being 6 by 6, times dy, the height from the location of their blue dot to the black dot. Again, this is the vertical distance, which, let me remind you, is 0. They're along that blue highlighter. Yeah, so it's literally just 1/12, 6 times 6 cubed, so 6 to the 4th. And what we're going to get for IX number 1 is going to be 108 inches to the 4th. Okay, if we do IX for number 2, again, we're going to have 1/12. The base is 5 inches, the height 4 inches, raised to the 3rd, plus again the area, which is 5 by 4, times the distance again vertically from the blue dot to the black dot, which again is going to be 0. So again, it is literally just going to be 1/12 base times height cubed. So we get, for number 2, for number 2, we get 26.7 inches to the 4th. If we sum up our IX's, right, we get our total. It's not really summing because we've subtracted them. This time it's going to be IX of shape 1 minus IX of shape 2. And we get then 108 minus 26.7, which is, who would have guessed it, 81.3 inches to the 4th, which is, by the way, the exact same thing we got over there. So again, really cool, right? 2 different ways to do it. Let's do it for Y now. Okay, it's a little bit more interesting in the Y direction than it is in the X direction. But if you needed IX, I think we could argue that this was much easier to solve for than the other way. But for IY, for shape number 1, it's 1/12, the height, 6, the base, 6, cubed, plus the area of 6 by 6, times the distance horizontally from the center over. So where's that? Well, let's remind ourselves where the center of this one is at. The center of this one is 6 inches divided by 2. And then we need to, we'll just kind of highlight this one out here. Again, so this center here is 6 divided by 2. And we know the distance to this point, which is x bar. So minus x bar. Ta-da, squared. And what we're going to get is 121.8 inches to the 4th. Okay, feeling like a pretty big number. That's okay. Let's do IY for shape number 2. So for number 2, again, it's going to be 1/12, the height, which is 4, times the base, which is 5, cubed, plus area, base times height, times, again, the distance for x. So again, different color here, trying to show this off. I'm going to take the full distance there to its center, and then minus x bar. Or we could kind of go the other way. However works. So the full distance to that one is going to be what? It's 1 inch plus 5 divided by 2, and then minus x bar. You can do it another way. You could say how much the total is from the other wall, actually. This can get a little bit fun. So we could say, well, how about what's the distance to here? And then I'm going to subtract off the remainder distance here. So, or well, the distance in that regard, it would be that direction to get the remainder. So it could have been going with the green direction. I'll highlight these. So we have the orange direction here. Don't forget to square that. And then we'll have the green direction right below it. And the green direction right below it is going to be 6 inches minus x bar, and then minus the distance from the wall over, which was 5 inches divided by 2. Ta-da, squared. So again, you have 2 different ways. Again, it's lovely. However you really want to figure it out. So it is going to give you the same answer, and the answer is going to be 66.8 inches to the 4th. So now let's remind ourselves. IY is going to be IY1 minus, because we're subtracting that piece out, IY2, and that is 121.8 minus 66.8, and this gets us actually 55 inches to the 4th. Ta-da! Slight little rounding thing here and there, but off by 0.1 inches to the 4th. Let's say that's the exact same answer. So you have multiple different ways to think about it. Whatever really kind of works for your brain is best. If you seem to not get the correct answer one way, just try it a different way. There's multiple different ways to solve the same math problem.